A major winter storm walloped
The bruising fight to win Tuesday's Republican
most dangerous virus possible.
In 1994, astronomers witnessed something that no one had ever seen before.
Scientists say it will be the most violent series of collisions ever witnessed in history.
A comet broken into 23 pieces slammed into the planet Jupiter, leaving scars in the gaseous atmosphere as big as the Pacific Ocean. Known as the Shoemaker-Levy comet, the event was recorded by telescopes around the world and recognized as the first planetary impact observed in space.
Today, the biggest impact yet, with an explosion so massive it temporarily blinded many telescopes.
We got to see impact after impact after impact, and then we saw material get thrown out into the atmosphere and blown around by the winds.
At the time, it seemed like a rare occurrence, but impacts like these are a natural phenomenon in the solar system, and it turns out a fairly common experience on Jupiter.
There was a fairly large impact in 2009, and then in 2010 we observed a fireball, and the other one is in September, and then in 2012 September there was the other entry flash.
As one astronomer put it, it looks like Jupiter has taken one for the team.
At the University of Central Florida, astronomers Joseph Harrington and Csaba Palotai are leading a project funded by the National Science Foundation that studies precisely how comets impact Jupiter and also provides valuable information about what might happen if a comet struck Earth.
We can say for Earth, these size impactors will be dangerous, these size impactors will not be dangerous.
A comet is a large rocky ball of ice that orbits the sun and usually has a long tail of debris trailing behind it. Sometimes a comet's orbit is affected by the gravity of planets and can be pulled onto a path that intersects the orbit of the planet, resulting in a spectacular collision.
A huge fireball appeared above the horizon, generated by a force equal to hundreds of atom bombs.
Jupiter's the biggest planet in the solar system.
Famous for its 300-year-old storm known as the Great Red Spot, Jupiter is over 1,300 times larger than Earth by volume and 300 times larger by mass. Because of its mass, Jupiter's gravity pulls in more asteroids and comets than any other planet.
Other than the sun, Jupiter is the biggest gravitational influence in the solar system, and it just generally acts as a bit of a vacuum cleaner for material.
Occasionally, these impacts are recorded by a telescope.
A photograph of Jupiter has captured a flash on the surface of the massive planet, believed to be the impact of a comet or asteroid.
The evidence, mostly blurry photos, are oftentimes all astronomers have to learn about the comet. By analyzing photos and other information, Harrington and Palotai are able to extract measurements and other information that they then plug into a 3D computer simulation. These models help determine other traits of the impact.
Based on this information that we get from observations, we run numerical simulations, computer simulations, and we try to determine the missing pieces of the puzzle.
The computer simulations first begin looking at the comet's entry into Jupiter's atmosphere. As it plunges towards the planet, the comet heats up.
As the atmosphere starts to get thicker and thicker as it plunges down, it's a few seconds before this large body of ice is being completely ripped apart by the atmosphere.
As the comet vaporizes, it spews a trail of extremely hot gas into Jupiter's atmosphere, creating a bright flash.
When we saw the flashes, we can get a size estimate, but was it a shallow impact? Was it a perpendicular impact?
The hot gases around the comet then begin to rise rapidly through the cooler air of the planet until it pushes through the atmosphere, creating a plume of hot gas.
It goes into space very slightly and falls back down onto the atmosphere of the planet, and then it spreads out over a very large range, tens of thousands of miles.
The computer models designed by Harrington and Palotai help them predict what future comet impacts on Jupiter might look like by allowing them to change the size, the speed, and other variables of the comet.
The more we work with this, the more interesting questions we find to answer. This can be applied to impacts on the Earth. It can be applied to impacts on other planets.
As comets and asteroids continue to share the space in our solar system, astronomers are studying their collisions with planets like Jupiter, something that could have a real impact back here on Earth.